People, this is the video segment for chapter 17 of my textbook, and the title of the section is Virtual Bolts in a Fastened Assembly. Let me put this thing in the slideshow mode. All right, so there is chapter 17. In the older release of older edition of the textbook, which was back in 2017 or 2018, this chapter was not there, and I've decided to put something about bolts in here, so that's what it is. Here's the setup, and we have a yellow part, which I'll call the bottom part, and there is a top part, the orange one, and these are fastened together at those two bolt holes, okay? And the left end of this clamp plate, yellow plate, is clamped, and the right end of this orange piece is subjected to downward force. Okay, so we're not going to be using three-dimensional bolt model. We're going to be using virtual bolt model, and the material is assumed to be elastic, and this is the actual force applied to the orange part, 1,000 Newton, and the bolt force or tightening force or preload force in each bolt is 1,000 Newton. Okay. Okay. Now, since I'm going to be assuming that the bolts deform, so I will use a deformable version of the virtual bolt. I need to specify the stiffness for it. Okay, and the unit of stiffness is like that in uh, 3D experience, which is kind of odd. Usually it's Newton per meter, and this has the same units, except this has the same type of units, except that you're gonna have to multiply it by G or divide by G to get convert from one to the other. Okay, the dimensions are given here. Uh, these are very simple parts, so I'm not going to be spending time on modeling them. These parts were already created, so I'm going to bring them into assembly and put it together, and then we're going to run the problem. Okay. All right. So let's see. Are we there? Yes. I already made the part, so let me go ahead and search under my contents. Okay, so I'm going to search under my content. First of all, I created an assembly here, so I'm going to search under my contents. These parts I created a few days ago, so I'll put it together. Okay, so let me sort this out by date. The two parts that I want are this one, the bottom and the top part. So let me see what's the best way of doing this. Okay, so this, oops, where did it go? Right there. This is the bottom one. I'm going to take it and put it in there. Okay, and there's the top piece and put it in there too. Top and the bottom. I'm going to close this. Right away, save it. Notice that I have to impose these two pieces together properly as an assembly with an assembly constraints. Now, in the book, I didn't talk about it. I assumed that they were already in position. This is why I didn't bother putting constraints here. And because of that, these holes may have not been uh, exactly lined up. That's why I got a warning message. But I'm not going to make that mistake here, so we'll fix it. Right click. First of all, let's change the color of these things. I changed this thing to yellow. This is the bottom piece, and this one to orange. This one to orange. Okay. And now we're going to go and create assembly constraints to bring these and put it together. So let me click on that. All right, so the hole up there and the hole down here, see, slightly moved it. These other two must be lined up, but just in case, so I'll do this and that. Okay. And finally, contact, bring these two together. So I select this bottom surface and the top surface and say OK. Whoops. I don't think I did this last one properly. Let's check it. Let's check it out. I'm not even sure if I actually, oh yeah, I probably accidentally pressed cancel. Okay, let's try it one more time. This axis and that axis, okay, this axis and let's try it. This axis and this axis, this axis and that axis, and then this face and this face. Good. Okay. Okay. We're in business now. All right. So these properties, these things have material properties. Uh, I don't really need these constraints. I can delete them. It really doesn't do anything. So I'm going to delete this. And yeah, material properties. These parts were already assigned material properties. However, there's a question mark here. So let me update. We'll worry about it later on. Okay. So this is done. I'm going to save this. Now we're going to go to now we're going to go to structural scenario, structure model. Sorry, structure model creation. But be careful, and I make a big fuss of this in the book. So right now I'm in one of the parts, and if you go to structural model creation, it will just mesh that part. So make sure before you go to structural model creation, structural model creation, make sure you're at the assembly level. So that means double click on the top line, double click on the top line, make sure you're in the assembly design, and now go to structural model creation. So what happens now is going to create meshes for these two simultaneously and put it at the top level right there. See, if I was in one of the parts, it would take this and put it in there, etc. And then I have to do some more work to work it out. Okay, this is fine. And now what we're going to do is we create our virtual bolt model. Virtual bolt model, we're going to use this one, okay? And it's asking for you support one. So let's start with this one on the left, the bolt on the left. So I select the top inside surface of that hole, and the second one, for the second, let me cancel this thing, show you one more time. So we go virtual bolt. Notice that the top one says support one, and then the second one is always ground unless you change it. So I want this surface, okay? And when I did that, because these were already lined up, it automatically picked the surface below it. But when you read the book, when you follow the book, because these were lined up, I had to select the top, and then for the support two, I had to select the bottom. Okay, so this is one step ahead, and I like it better here. In the book, the explanation says for support one, take the top face, top hole, and for the support two, select the bottom hole. Okay, and it let me do that. Uh, but here, because I already put constraints on them and they're lined up, it automatically picked the other guy. Okay, as for the type of the inside nominal diameter, 10 millimeter, okay, the diameter of that hole is 10. And for the stiffness, I will put, it was 1 e to the 6, I believe, e to the 6. Okay, and yeah, just say mesh. Okay, Now, I do exactly the same thing for the other bolt. So let me close this. Okay, so we can hide this mesh. It's easier without it. So let me see now. Right click, mesh visualization manager, mesh hide. Very good. Let me put this thing on the side here for you. Do another bolt. See, it says ground here. When I select the top one, automatically it goes select the bottom one because they were already lined up. And I put the same stiffness, right? Same stiffness. They don't have to be the same stiffness. It could be that they're different bolts, different type of bolts, but that's not what we're doing. Update mesh, okay, and say okay. Good. Save it. All right. Notice that when you look at nodes and elements, you have the standard tetrahedral mesh for the yellow piece and the orange piece. You can go change it, you can go change the type, you can go change the size, and there are also two visual bolts that are created here. Okay, so we are done there, and uh, we're gonna go to scenario, creating scenario, structural scenario creation. It's a structural problem. All right, notice that the usual two exclamation marks. So the first one is set up. It says select your finite element model. And I select uh, this. Now, once again, in the book, there is something on top of that. And probably that was created because of the fact that these two holes are not lined up. But this is fine. So I select this and I say OK. Okay. Notice that this turns green. Now we're going to do the procedure. It's a static problem. As soon as I do this, this guy is going to light up and it's going to turn green. So what I'm going to do, I'm going to make this thing, initial time, I'm going to make it smaller because I don't want this thing to be only 2 steps. I want to make sure that at least it goes a few steps so that I can see the development of the deflection. And this one I'm going to make 0.5. I don't want it to be too big. It will work with what the defaults are too. You say okay. And if you want to include nonlinear geometry and large deformation, just check this thing. Otherwise, leave it out. We will include it. Okay. So now we're going to apply our restraints. So let me hide this mesh. Right click, visualization management, hide the mesh. Okay. Put this on the side here. So we're going to go to restraint. This end is clamped. This end is clamped. Okay. Clamp that end. Okay. The end on the right side, I apply 1,000 pound on it, 1,000 Newton on it. So we go to loads, force on that face, minus 1,000. And you can see that's down here. Now I have to do the bolt forces, the preload or the tightening force. So if you look here, there is a bolt force, and that's the one that I want. It's not the torque bolt force, and support is bolt 1. Now I can do that from the tree or I can do it from the screen. Okay, so I select it from the screen. This is bolt 1, and I put 1,000 Newton in it. Remember, that does not have a direction. This is just the tightening force, which make the bolt to basically stretch, and it clamps the two pieces together. Okay, and then apply or okay, and do another one for the other fellow right there. 1,000. What is it? 1,000. Say okay. All right. And yeah, now if I run this thing, it'll bomb out because what happens is that these two pieces don't see each other. So I have to create a connection, a contact connection between these, a contact constraint between them. So we're not done yet. We have to create an interaction, and surface to surface, surface-based contact. And for the master, I'm not sure exactly what I did in the book, whether I selected this or the other one. There are some guidelines, but it really doesn't matter that much in this problem. They're simple enough. I'm pretty sure I selected for the master that surface, and for slave this bottom surface. There are some guidelines for selecting these, and if it doesn't work, you can come and flip these, but that's okay. This will work. Say okay. And that's it. So these two are not going to penetrate each other when we save everything. Okay. So we're going to go to simulate. We check it. Yep. You okay? We do a simulation check. Any error messages, warning messages will pop up at this point instead of running it and realizing there's a problem. Now, in the book, I got a variety of warning messages because of that thing that I showed you, that constraint that I showed you. Here, we'll see how it goes. Let's check that kind of message it is. Yeah, that's fine. The kind of messages that I got without aligning those two is different. Okay, no messages, no errors. And now we're going to run it. So while this is running, I want to remind you again that the only difference between what you see here and what's in the book is that in the book, I did not apply those restraints, those access-to-access restraints, constraints for the assembly. And this is why I got some messages saying that these are not lined up, these holes are not lined up. But it did run, so probably it did run. That's pretty much the only difference. Now remember, these tabs tell you at what stage of the iterations you are with respect to a plot. I mean, giving a plot and an iteration number, etc. So far, no error. These warnings are the same thing that appeared in the previous window. So, solving simulation. Okay. Iteration is right. Iteration count is over here. Okay. When it reaches 1 means done. The full load was applied, and it did reach 1 right here. Okay. Close this. Okay. So this is, of course, at the initial frame, which means no load applied. So if you go to the next one, you see that this thing begins to bend. And of course, it's like a cantilever beam. Biggest stress is going to be there. And then you go next one, etc. And the last stage is this. And you look at the deformation, displacement. Okay, first step is right here. These values, of course, mean something, right? So the last stage is here, 12 millimeters. This tip is deflating 12 millimeters. But if you look at the side, you see that there's a lift off here. Okay, what that means is that the force of this bolt was not sufficient. So what I'm going to do is I'm going to double this force. Okay, remember it was 1,000 Newton. I'm going to double it up. So let's go back to the scenario here, and under loads and under the bolt force 1, I'm going to double click on it, and I will change this thing to 2,000 and say okay. And since I know that this, in all likelihood, will not have a problem running. So I'm going to say simulate. And we're going to look at exactly that corner to see whether there is that much of a gap in between them. In fact, the gap will reduce substantially, and the deflection, because of that, this deflection is going to be almost, I think, half of that, half of what was originally, okay? Which makes sense, because if the bolt is not strong enough, this not only deforms, but it also moves as a rigid body upward. So it's kind of a rigid body upward. Okay, it's coming along. It's almost done. So this should go 100%. And yeah, extracting results. So the solution is done now. It's getting results for post-processing. Okay, good. So close this. Notice that, remember this deflection was 12 millimeters. Okay, now it's down to 1.46 millimeter, and these two maintain contact. Now, there's something else I want to show you, and that is the following. What if I remove the concentrated load here? Well, there's still the preload in the bolts, and there must be some stresses. So I'm going to delete this. Yeah, I'm going to delete this. I'm going to run it again. Where are we in this scenario? Let's go back to scenario. The concentrated force has been deleted, so we're going to run it again, and we're going to see that there are some stresses, and that's due to the clamping force or the preload in the bolt. There's no external force on this structure, but there is the preload. Just give it a couple minutes, and you'll see it. Now, the reason I added this chapter was one of my colleagues at Wichita State is using the software and the textbook for his machine design course, and they felt that it would be helpful if they had a simple problem which involved bolt bolt design, and this is the simplest one that I could think of. Extracting results, doing finite elements, doing for post-processing purposes. So give it time. There we are. Close it. Okay. So if you look at the one meter stress, you see there's no load on the structure, but the fact that the bolt is tightened, it causes a stress in this bar and a stress in that bar. The force here was the tightening load was 2,000, double of that. This is why there's more greenish thing here. All right, folks, good luck. Meet you again.